I told you yesterday I wasn't sure if I wanted to do this or not, and then I just decided that I think it's worthwhile to talk about this area of similar polygons. It kind of shows up on like standardized test stuff. And because it's not that bad, I feel like it's something that we can do. This chapter is really short, so I hope that means, one, it's area, and for the most part we feel pretty good about area, and two, it's short. So I'm hoping this is a really good chapter test for us. So, similar polygons. We know similar polygons are same shape, different size. We learned a couple chapters ago that they have the same ratio of size, right? We call that the scale factor. Well, if we're talking about their areas, that scale factor still matters, but think about when you do a scale, or when you do area, you're squaring, the units, you're squaring base times height. So when you do the ratio of similar figures, you find that scale factor, but you have to square it, all right? We talked about converting a square inch to a square foot, that you have to square that. So the same thing here, you have to square that scale factor. If you're talking about volume, you have to cube that scale factor when you're doing that, all right? So remember that a scale factor is just the ratio of two corresponding sides. So they said FG over AB, but that could be FJ over AD, right? We feel good about similar things. Do I need to review that? All right, let's just jump in here. Yes. So it says, find the area of the similar polygons. If ABCD is similar to PQRS, and the area of ABCD is 48 square inches, find the area of PQRS. Remember, we have to find the appropriate sides that go together. So CD corresponds to which side of the other rectangle? Right? So notice they're not the same, they're not turned the same way, so just be really careful on that. So we know that we could find that scale factor by taking CD over RS, right? So we could say our scale factor is CD over RS, which is just 6 over 9. Are we going to leave it at 6 over 9? You could, but I'm just going to simplify it. Is it okay if I change that to 2 over 3? So that's my scale factor. The ratio of my areas, I need to square that scale factor, right? So I think I kind of stole this from the book a little bit. Like we could say, oh look, why did I do it? No, it really doesn't matter, right? Like I just have to remember that this one I'm doing, if I was setting this up, I'll show you the book set it up. I would set it up as the area of ABCD over the area of PQRS, and that's going to be equal to 2 over 3 squared. You with me on that? Look what they did. They said the area of PQRS over the area of ABCD is 3 over 2 squared. Are those two things equivalent? Remember with a proportion, as long as your means and your extremes work out, you can write them in different ways. So both of these are going to give us the same proportion, but just make sure you know that it matters how you write that of what you put across from it. Does that make sense? So which one, we can do both if you want, but I think they did PQRS because that's what we don't know, right? We're trying to find PQRS, so they left that on top. And then they plugged in 48 because they tell us that the area of ABCD is 48. And then remember, when you square a fraction, you square the top and the bottom. I'm going to do it my way too, just to show you it's the same. So I would have said 48 over the area that I don't know, area of... And then if you square that, I would have 4 over 9 instead of 9 over 4. Right? Again, it's the exact same proportion, because in both of them, if you cross multiply, you're going to get 48 times 9 and 4 times this. And so up to you how you want to write it. If you think about the way we did log sines and log cosines, I said, why don't put what you're looking for on top so that it makes life easier, right? Like, would you cross multiply to solve this, or would you just multiply both sides by 48? There's no wrong answer there, right? It's just what makes the most sense to you. Over here, I would have to cross multiply because that area is on the bottom. But just to kind of remind you, if you just multiplied by 48 over here, right, you would have what you're looking for by itself. But you could cross multiply and then divide by 4 again. It's going to work out the same way. 4 goes into 48 12 times. 10. Oh, I don't have any. $108, is that true? And that would be the area. There's a really easy way that you could check if you were right, especially if this was a quiz or a test. You could take the ratio of your areas and make sure that you got back 3 over 2 squared, or 9/4. And so if you took 48 over 108, you put that in your calculator as a fraction, do you get 9 over 4? Wait, did I have it the wrong way? I guess.
Yeah.
Oh, look, look, sorry. I'm doing it my other way.
Yeah.
108 over 48. Sorry.
Yeah, you did.
Either way, 9/4, right? You can see the thing, whichever way you write it. 0.4 repeating is 4/9. They have it as 9/4. But I'm
Either way.
right. So as long as you get that ratio, then you know you did that correctly, and you don't have to worry about if you did it right or not. Questions on that? The big thing is to remember to make sure your scale factor matches up with it, and to make sure you remember to square that scale factor. Now look at this one. What if they give you the areas? On this one, they give us that the area is 98 square inches and the area of RTS is 50 square inches, and they tell us that they're similar. Find the scale factor from triangle ABC to triangle RTS and the value of X. So in this one, they give me the area of triangle ABC to the area of triangle RTS. Right, so we could work backwards on this one. So 98 over 50. Do you know how to use your calculators and get fractions all the time? 49 over 25. So, first of all, if you want fractions, this is your ABC button. So instead of hitting the divide button, you're going to hit 98 fraction bar 50. But your calculator gives you mixed numbers, and in math, you don't really like mixed numbers. So that's improper fraction. You can make the mixed number improper fraction the old school way, where you make the whole numbers at the bottom and at the top. But if you hit second and the fraction button again, where you see where it says ABC to D over E. So if I have, if you hit second and the fraction button again and you hit enter, it will always change that to an improper fraction. Which means that this reduces to 49 over 50. 25, sorry. You with me on that? It's really nice to know how to use your calculator. You also could just reduce that by dividing the top and the bottom by 2. That's another way you could reduce it, right? Yes, dear. Well, we need to reduce it because this is the ratio of the areas, yes? So it's going to be a lot uglier if you don't reduce it first, because this is the scale factors squared, right? So what do I need to do to go backwards and just get the scale factor? I need to square root it. This is going to be a lot uglier to square root than this is. Do you agree with that? So that's why you want to reduce it first if you can, and hope that it's easier to do. Because now if I want to just get the scale factor, I'm going to take the square root of the top and the bottom. And what is the square root of 49? It's just 7 over 5. You could do that up here, but then you're going to have to simplify those square roots, and it's going to be a lot more work. to do that. So this is your scale factor. So we've kind of approached this problem like these both ways. On the last one, we could find the scale factor and then we could square it to find the areas. If we're finding a side, we need the original scale factor, not squared. So we have to square root it. And now we can set up our proportion. So what am I going to put on this side to correspond to this 7/5 scale factor that I wrote? Right, because 7 was ABC, so we have to take 14 over x. So it seems like I kind of said it backwards, but if we cross multiply, it'll all work out. Then I'll get 7x equals 70, right? 70. So then I get, so it says find the scale factor, which we found, and the value of x. So x equals 10. And again, it's really easy to check that that's correct because 14 over 10 should reduce to 7/5, which it does. If you just see, right. What did you do? You did 98 over 50 or 50 over 98? You did this? So he said, instead of going backwards and taking the square root, he said, well, if I know this is the scale factor squared, then I can just take the ratio of those sides and square it, and it works out. Maybe, I don't know which is more work to do, but you get x squared over 14 squared, which is 6. And then you cross multiply and take the square root of that. And that works. I would never thought of it that way, but it totally works to do that. I was thinking we just had to undo the square by square rooting, but you just squared the sides. So it worked out just fine. Yeah, that works. But you're right, the only thing you're missing is the scale factor. So you would still have to be able to... Oh yeah, then you can just take your answer. That works. Yeah. That sounds so bad. Well, if it doesn't work out to be a nice number, if it's a square root, 2 options. If it says round to the nearest tenth, you can just do the decimal. The other option is we get more practice with simplifying those square roots, right? Like, let's say you would have got an answer, if you would have got x squared equals 50, or even for us, if we would have square rooted this and got ugly answers, usually your geometry book says you can round to the nearest tenth, so you would just have to give ugly numbers. But if it said give an exact answer, that's where you would leave it as a square root. All right, let's take this one step further. The area of one side of the skyscraper is 90,000 square feet, and the area of one side of the scale model is 200 square inches. If the skyscraper is 720 feet tall, how tall is the model? So the area of one side of the skyscraper, I can't draw three dimensional shapes. I'll just set this up. So like they're giving me area, right? And then the model of the same thing, but its model is 200 square inches. So do we have an issue because one's in square inches and one's in square feet? For telling me before I knew something. That was like yesterday. That's all right. Missing a zero is always annoying when you're like, what's a zero? So we need to figure out how many feet are in a square inch, how many inches are in a square foot first, I think. Gross. That's gross, right? So what do we know? There are 12 inches in 1 foot. So if we're squaring it, there's 144 square inches in 1 square foot. So here's the question. Do we want to change that 90,000 into inches? Which is going to be a whole lot of inches. Or do we want to change the square inches into feet? So if I have 200 inches squared and I want to use this conversion, could I multiply by 1 square foot over 144 square inches? Right, like that's our whole conversion factor. Because then 1 square foot is the same as 144 square inches. Which means it's not going to be pretty, alright? So 200 divided by 144, like 1.38888888888888. I have to take 200 divided by 144. Yes? I'm multiplying 200 inches times this conversion factor. 1.38 repeating. Well, so that's because it rounds up at the end. But that's really just 0.8 repeating. But that's, I do know that actually. So I'm saying in 200 square inches is the same as, like, I'm just going to say we're going to round 1.39 square feet. Right? Because the inches cancel out. Unit conversion. Next year we can get a 3. So now I have them in the same unit. And they gave me the area compared to the area. So just like, so I guess we have options now. Because we have Garrett's way. Do we want to square it? Do we want to square it like Garrett did, or we want to square root like we did? So we can say, if we compare big to small, that would be comparing 90,000 square feet compared to 1.39 square feet. Right, so it's important that we have the same unit to find this. That's our areas, right? So I'm going to write that. Areas. Which means those are my scale factor squared. So I have to take the square root of that. So Allie, this is where you mean. Like, what do we do when it's ugly? We're just going to get a decimal. Okay? Or we could get a decimal on the top and the bottom. I don't know what you want to do. I say we just get a decimal. Are you okay with that? I'm going to just type this in all at once. I'm going to take the square root of 90,000 divided by 1.39. I got 254.46. If you're right, plus 25. And again, I'm not writing that very good as a scale factor, but I'm just going to leave it like that. Let's see if this works, if we get the same thing with gear kits. So now, if the skyscraper is 720 feet tall, could I say, I'm going to come up here, you can go there to look. If the skyscraper is 720 feet tall, and I'm looking for how tall the model is, can I set that equal to, and since I didn't write this as a fraction, could I write that as 254.46 over 1? Or just 254.46? You ever see like scale models with like 1/36 scale or 1/64 scale? Which basically means that if we cross multiply, we have to take 720 to divide that, right? I just said for how tall is the model, but it's just for our missing, whatever letter you want to use it as. I just used it because it was the model. I think so. What's my units on this? When I solve for that model, am I in square feet? Am I in square inches? Am I in feet? Or am I in inches? I'm in feet because we have square feet, and when you take the square root of square feet, you get feet. Did you not get that? I took 700, because I cross multiplied, so I got the 254 on this side, And so I took 720 divided by that. 720 divided by 254.46. Since the model is in inches, they want your answer back in inches too. So now you just got to convert 2.83 feet back to inches, which is not bad to do. 2.83 feet. There are 12 inches in 1 foot, so you're just going to multiply by 12 here to get that. The height of the model, I guess I could have used h for height. I'm going to get to about 34 feet. I got 30, well, I'm just going to say, sorry, inches. 33.95. Garrett, how's it going over there in your way? Sometimes squaring, making it quadratic is not the most fun to do. But guess what? That's the answer, 34 inches. Approximately 34 inches is what they said. The hard part with actual scale model stuff, which is where scale factors come into play the most in real life, is you do have to do unit conversions. So that was really the ugly part of that. Okay? So hopefully, this will be so bad. 15 is like a story problem, and then there's just a couple other ones at the end, maybe some review as well. But you have about 15 minutes, so use your time wisely. Remember, you get points for using your time wisely.